If people have questions, as always, feel free to ask them, either in the chat here or on Piazza. Yeah, there was a question today that I answered, and it seems like last week's one were about assignment and test issues, so hopefully people all got that sorted. We had some madness with the test last week and kind of giving you guys some other options to do it, so hopefully that worked for everyone. Yeah, I'm going to try and find time to go through and make sure all those like I said in the announcement, we'll have different versions of, we'll basically mark them in order. So if you had to do the CrowdMark one over because you didn't see that PDF the first time, we'll mark those first, and we'll just make sure everybody gets graded on the thing they actually submitted. So that will get all worked out, and the TAs are getting close to finishing assignment 1. So once they're done that, we're going to all put our heads together and mark the final part for the test. Yeah, and once I confirmed the online part worked, that everybody got fairly kind of had a chance to submit, I can release the auto-graded part of the quiz. But, from initial looks last time when we were going through in the middle, it seemed like people were doing pretty well on all those questions. So yeah, I guess for this course, your focus now is getting deeper into assignment 2 and doing it, because you're trying to submit that in, well, 2 weeks still. So I think some people have just started looking at that. Had some questions about the data on Piazza. And like I said before, I don't think it's in a way super complex conceptually, but you do have to kind of run a bunch of different algorithms on the same data and some feature extraction things on the data, and then use those as your algorithm. So there'll be a bunch of permutations of the same type of thing. So you'll want to get started on it to at least get the first basic algorithms running on the data, so you understand all the setups. If you have any questions about features or anything like that, we can try to sort that out sooner rather than later. Yeah, and then test 2 is going to be the next test, kind of the week after your assignment's in, on all the things people hopefully are watching on YouTube recently. So I'm going to go and check the stats numbers and see where people actually are on YouTube, because that's one of the hard parts. When I'm not teaching this online, I can't tell where everybody is, if they're up to date or not. But we're basically been going through right now unsupervised learning topics, right? Clustering, is that this week or next week? I have to remember too. So we are in week 8 right now. So the idea is, yeah, there's where is it on learn? I'm just trying to update some of this on here in terms of the lectures. And don't freak out if you're behind, because some of it's like you're busy with a bunch of things and the numbering is off from YouTube. So we're putting in some buffer to let people catch up, but it'd be a good thing to try to sense where everyone is. So last week was week 7 for us. On YouTube, it was week 8 lectures. So that's what we're talking about. The last kind of supervised classification algorithm, support vector machines before neural networks. And then kind of introducing unsupervised learning and clustering as a problem. And then This is week 8. And the week 8 lecture is quite short, so if you're behind on the other one, you can kind of check on these ones. I think it's short. And it's on anomaly detection, which can be seen as kind of a subset, a type of unsupervised learning problem where you're looking for error data and stuff like that. So that's the idea of where you should be looking at now. Basically looking at things from week 7, week 8 on YouTube. And that would get you to all the things that are needed. These ones from this week, these lectures are the last things you'd need for test 2, which is the important part, because after this, we'll be having stuff on deep learning, which you'll need for the final assignment and final test, but this week's lectures are all you need for test 2, which is sorry, let me just have that here so you can see it all at once. And then I'll look, there are some questions, so go to that. All right. Great, so Travis has a question for test question 13. Having test accuracy higher than your training accuracy. True. Yeah. Yeah, one of those questions of what do you want if your test accuracy is like on the test data, right? You've got like, well, is that true? Well, yeah, you expect your testing accuracy to be lower than your training accuracy, right? Yeah, because in the training data, you get the labels, you see the answer, and so you should be able to do really well at it, right? If it's a simple data set, you should get 100%. If it's a complicated data set and you're using a simple model, maybe you can't get 100%. Which, like, for example, the ones if you looked at those videos last week on support vector machines, if you're using a linear support vector machine, you're trying to fit nonlinear data with a linear kind of cut, you may not be able to get 100%, even on the training data with the full answers. If you're using a nonlinear kernel for support vector machines, you could do better, but it would depend on whether you're using the right kernel or not. So you might still not get 100%. But on your test data, you don't know the labels, you've never seen the right answer, so you're checking the accuracy without being able to learn from it. You'd expect your test accuracy to be lower. Yeah, so that would be the related way to do it. And so that question on the test, that would be the right answer, yeah. Oh, okay, Trav, that's why you're asking you say you got it wrong. How did you know you got it wrong? It was telling you if you got it right or wrong. It's not supposed to tell you right away. Okay, but that'll be a thing for us to check because yeah, as I keep saying with the way to learn quizzes and all these things set up, it's hard to know what you guys see when we set it up. Since it's a test, I had tried to set it up so that you don't see the answer when you're doing it, so you don't worry about that. You just give your right answer and then you find out later. But maybe that's not the way it worked. Yeah, as always, we'll check over the grading scheme. I can adjust that after the fact and make it correct, but that's surprising. Yeah, let me add that into my little note for corrections. I have a whole spreadsheet for this kind of thing. Okay. In terms of the solutions, somebody's asking about the solutions. I'll have to generate the solutions. It's hard to print it out from the way Learn does it. And I don't necessarily want to do it for multiple choice because sometimes we want to reuse questions. But you should be able to see whether you got it right or wrong in the system if I can set it up that way. And then you could come argue about it if you think you're right, which can happen. But for the data ones where we give you the figures and show you the right answer, that one we could give you the answers as well, because that's kind of computed and changed every year regardless. So we have a question about clustering there from Jishuan. Yeah, so generally, if you like, this is about talking about clustering in general as algorithms. Your question is about how do you know how many clusters, essentially, right? Which is better, yeah. That's unknowable. It's one of these things where it's kind of like, hopefully I said that in the YouTube lecture of it, but when we're doing in supervised learning, we can have our table here, right? In supervised learning, we know the right answers, right? So we can compute error, we can compute accuracy, and we assume that these right answers kind of are meaningful in some way. If they're numerical, then really we're trying to predict something direct. So like in your assignment, you're trying to predict the class that, tells you this thing about whether a particular statistic's going up or down for COVID. So it's right or wrong, right? And it's not always true because the classes could be subjective, right? If you got classes that were labeled by humans in your data, it could be that the classes are defined subjectively, so it's not really 100% provable that it's right in a true sense. You could be right because you got the labels correct, but what were we arguing about, my friends the other day? Tomatoes versus fruits versus vegetables, right? There's some clear definition of it. If food has seeds inside, it's a fruit or something. But lots of people like to argue about whether something's properly a fruit or a vegetable because it feels like a vegetable to you rather than a fruit, right? I have trouble thinking of tomato as a fruit, even though technically people say it is. Seems like a vegetable. So, but you could argue about whether that classification, whether that labeling is correct, right? But a lot of times the labeling is very distinct. Cats and dogs are cats and dogs, and this stock had this value. But in clustering, it's much less likely for that to be true because we often don't know, we don't have it labeled for all the data, right? So people label the data partially, and the clusters are supposed to kind of give you meaningful groupings. So a cluster could be defined, precisely in terms of numbers and say the cluster is defined in this exact way, so they all have this property. But a lot of times it's something more subjective, right? So a lot of unsupervised learning, the thing you're trying to actually get, you can't completely confirm that it's correct, right? That doesn't mean some aren't better than others, right? So you can have a clustering where data points that are more similar are near each other, and it really is useful for compressing the data or for classifying the data or for using it. But is it the correct clustering? It may not be something that you could really say for sure, right? And the same goes for what you're saying is what's the right number of clusters, right? Because we could argue about the number of clusters that some cloud of points should have, right? So in the slides, I must have had a plot somewhere with points. Can I jump more directly? You don't know how many clusters there should be, right? So in this one with the k-means plots, we're saying there's 3 clusters because we colored them that way and they're labeled, but it's not clear. If they weren't colored, you could say there's some different number of clusters, right? But it depends what's useful for your task. So I think, especially as engineers and, data scientists, whatever you're building it for, the number of clusters you pick should be the one that's useful for your task and what you're doing. So if it's about reducing the amount of data or making an efficient kind of search between objects, the number of classes will affect that. Yeah, and so in some tasks, I think you might prefer to have a large number of clusters versus a small number, because you really want to capture kind of local differences. Like maybe you want all of these little groupings to be clusters for some purpose. If it's about population data and people, there could be lots of patterns. But maybe it's something, if your task is something more broad, like who should get the vaccine next, it's like, okay, well, we want to divide everybody into like 3 or 4 groups. That might be useful. But there's no clear number. It depends on where you're doing it. Data set link not working. Oh, okay, I got fixed. Okay, so on the testing and training, Albara has an alternative approach there, which is a good point as well. I kind of dove in on the other side. You expect your testing to be lower because if you're training on a large data set and you're testing on something smaller, you don't expect to do as well as you did on the training data. But there is this idea of generalization, right? So if you're generalizing really well, that means you can do well on points you've never seen before, right? But could you do better on those points than on points you have seen before, right? So if I give you a mixed data set where a bunch of them are very similar to ones you saw and some are quite different, and you do well on all of them, you'd still expect your overall accuracy to be lower than on the training data. But I'm sure you can construct an example where, yeah, there's some cases where the test accuracy might actually be higher because you're doing really well at generalization, but it still seemed like it'd be okay on the normal points, right? So I guess if you've trained, yeah, also overfitting, that's what you said, which is a good, well, overfitting. Yeah, so I mean, overfitting is the problem of training too well on your training data, right? So getting your training data up super high usually is how it shows up, right? That you do really well on your training data, maybe perfect, and then you can't do well on the test data at all. So when you're overfitting, usually it's even more exaggerated, that your test data is much less. Your testing accuracy is much less than your training accuracy. I think, yeah. But you're right, generalizing well is very important. So I bet you can construct some cases where the generalization benefit somehow outperforms something else, but I think that'd be rare. Yeah, and so, okay, back to test 1. Yeah, the test score, if you see a score up there right now, that's not the complete one because we do have to mark the NLE map question manually, right? So you're definitely you're missing, everyone currently has 0 on the final question, which you answered in on the derivation, right? And you won't get 0 on it if you submitted an answer. So yeah, just don't worry about the test final thing right now. But like I said about letting you check and help us make sure we're grading all the questions properly, I'll see if we can make it that you can interactively look back at your results and see each one, but I'll have to get to that probably tomorrow because I have the other class today.